Okay, so let's go through these notes. This is going to be short and sweet. We talk a lot about tangent lines in calculus, and what you have shown here on the picture is we have a parabola, and this would be called a tangent line. So a tangent line is in the same direction of the curve at the point of contact. So its contact point is 1, 1, and then it's only going to hit one place. Hence, there's just one contact point. Whereas secant line, it passes through the curve twice. So an example of a secant line maybe looks like this because it intersects the curve twice. So that's called a secant line. So it says fill out the table below to find the slope of the tangent line at x equals 1. So we're trying to find the slope of this line right here by plugging in some points. So when x is 1 and y is 1, x2 is 2, and what would y2 be? Okay, so I think what this is showing is this is the point they have in contact. That's why this is the first column, or the first and second column are all ones. And then it's saying, hey, what's the curve at 2, 4? So at 2, you know the parabola is up at 4, right here. So then the slope would be y2 minus y1. So that's 3 over 1. And that's where we get the slope of 3. So what we're doing is we're taking this point 1, 1, and then we're comparing it here, and we're finding the slope of that line. Now let's find the slope of when x is at 1.5. So now when x is at 1.5, where's that on the parabola? It's 1.5 squared, which is 2.25. Now let's find the slope. We should change colors. Okay, so like this line right here would be this pink dot. And so the slope, we could kind of draw it on like this. So now the slope is 1.25 over 0.5, which equals 2.5. Now I'm going to do green. Okay, so we're getting closer and closer to this dot. So let's do this. So 1.1 be about here. So now we're getting a little bit closer to our actual tangent line. So the slope would be 0.21 over 0.1, which is 2.1. And then what you're going to see happen is we're going to get closer and closer and closer to that dot. And you can write those down if you want. But these numbers are getting closer. It's kind of like a limit. Start at 3, and now we're getting closer and closer and closer to 2. So the slope of the tangent line at x equals 1 is 2. So this tangent line that was given to you, the slope of that is 2. Okay, so we're just going to kind of go through an example problem here on the back. It's a heartbeat of a patient after surgery. So 36 minutes after surgery, this is their heartbeat per minute. That's how many times their heart was beating. What, in a minute? That's a lot. The number of heartbeat, after okay, in 36 minutes maybe, this is how many times their heart had beat in 36 minutes. That wouldn't be per minute, that'd be crazy. Okay, so let's go ahead, and what they want us to do is calculate the slope at time 36 and time 42. So these 2 points here. So you do change in y, that's where I got my 418, over change in x, and that's where I got my 6, and that's about 69.6 as the slope. So then they're like, hey, let's instead compare 38 and 42. Let's compare these 2 points and see what happens. And you see there the slope is 71.75. All right, let's see what the slope is between 40 and 42 seconds. So now you're subtracting these y values over 2, and that's about 71. And then they have us do between these 2 times, and that's where I get 66. So what I chose to do, like, what are your conclusions? Well, if you kind of look at all the numbers, what I chose to do is, of the 4 numbers, these were the closest together on the chart. So I don't know if this is necessarily perfect or the right thing to do. It's just this was my conclusion. I averaged the 2 closest secant lines. The average of these was about 68.5, 42 minutes after surgery. So the patient's heart rate is about 68.5 beats per minute. The only assignment that goes along with this, so on notebook paper, just 2 questions similar to what I just did with you. So page 86, 1 and 7, and if you could have that done by Monday.